We're now going to take a look at the second of the solid principles, which is called the open-close principle. But also there is a bit of an added benefit here in that in addition to looking at OCP, the open-close principle, I'm also going to show you one of the enterprise design patterns. Now, this course isn't about enterprise patterns, it's about the classic design patterns, but we are going to see one of those enterprise patterns in this course. So let me first of all explain to you what's going on. So let's imagine that you have some sort of website or something like Amazon, and you allow people to search for different products based on certain criteria. So let's suppose that we have a class called product. So a product is going to have a couple of attributes. It's going to have a name, but it can also have, let's say, a color and a size as well. And we're going to keep all of those as fields. This color equals color. This size equals size, rather. And we might want to define a couple of enumerations. Now, JavaScript doesn't have enums, so we're just going to do it the good old-fashioned way by defining objects which are frozen. So we're going to say object.freeze. And I'm just going to have, let's say, the color. We're going to have three colors, red, green, and blue. I'm just going to keep them as strings as opposed to any kind of composite object. So I'm going to have red being defined as a string. I'm going to have green, also a string, green, and blue. There we go. Okay, so in addition, we might have different sizes of objects. So once again, I'm going to do exactly the same thing. I'm going to define size as this object where I'm going to have small. I'll have medium, and let's also have large, like so. There we go. So we now have a way of speccing out the different objects. Now, what we want to be able to do is we want to filter objects by certain criteria. So you might be tempted to build some sort of product filter. So a product filter is going to have a couple of methods which take a bunch of products as well as some criterion, and they're going to filter those. Now, you're probably wondering, well, hold on, can't we just take a function somewhere? Can't we just take a predicate and then do it on the predicate? Well, if you think about a website like Amazon, they don't really let you filter on every single criteria of an object. They only let you filter on some of them, some predefined criteria. And besides, in the real world, filtering by certain criteria can be optimized. For example, you can do some of the filterings on the GPU as opposed to the CPU, stuff like that. So let's imagine we want to filter products by color. So we make a method called filter by color, where you take a bunch of products and you also take the color you want to filter by, and the implementation is really easy. You just take products.filter, and then you for each product you have to make sure that the color matches, like so. So that's pretty much it. This is something that we can actually already work with in the sense of building our scenario. So let me make a couple of these supposed products that we're going to sell. So we're going to be selling an apple, which is going to be a product called apple, which is going to be green and small. Okay, now in addition, we'll have a tree. I'm just going to assume that you can sell trees and, well, gardening supplies and all that. So we're going to have a product called a tree, which is also going to be green, but it's going to be large. And in addition, we'll have a house. Now, a house is going to be a product which is called house. It's going to be maybe some other color, maybe blue, and it's going to be large as well. Although a house is larger than a tree, but it's all relative. So we're going to have this list of products. So let products, just going to put them into an array. So apple, tree, house. That's what we want to filter. Now, we already have a way of filtering by color. So what we can do now is we can find all the green products. So I can say let pf equals new product filter. And then I can, let's output some log message here. Green products. Using the old approach, because then we're going to do it in a brand new way. So I'm going to go through every product P of product filter by color, and in filter by color I specify the products as well as the color I want to filter by, like for example color green. So I want to find all the items which are green and output them to the console. So here I'm just going to say p.name is green. There we go. So this is something we can run, and as you can see, here's the output. So apple is green and tree is green. So everything is working correctly. Now, suppose that our boss comes back and the boss says, well, can you please also filter by size? So this is, of course, doable. And we can go back to product filter and we can add another method. we can, for example, filter by size, products, color, blah, blah, blah. And here the implementation is going to be very similar. In fact, it's almost like cut and paste programming. You just specify size here, and not just here, but also in the argument, and also here as well. So this is how you implement this. Now, this is where we actually get to talk about the open-close principle. What is it all about? Well, essentially, the open-close principle states that objects are open for extension. Let me just write this down. Open for extension, but closed for modification. So what do we mean by extension? What do we mean by modification? Well, as soon as I jump into product filter and I start adding additional methods, that's modification. I'm modifying a class that might have already been tested, might have already been deployed somewhere, and I'm making changes to it. This is considered not as good as actually extension. And by extension, we mean a lot of things, but typically we mean inheritance. We mean that a class inherits from another class and automatically acquires some of its fields, some of its members, and then adds additional functionality. So the whole idea of OCP, the open-close principle, is that this filter, once it's defined, once you add the filter by color, you've tested it, you've put it into production, you don't modify the class anymore. And we are breaking the open-close principle by adding another filter here. Because imagine, well, we put this filter into production and it gets tested, it gets put into production, it actually runs on the website. And then the boss comes back and the boss says, well, can you also please filter by both size and color? Because some of our users want to filter by both. So we go ahead and we implement yet another method. Size and color. So you take a bunch of products, you take the size, you take the color, and here you do a similar thing. So you return products dot filter. So here you have to specify that p size is equal to size and p dot color is equal to color. So this isn't really a problem to write, but if you think about this thing kind of scaling out, what you're going to have is you're going to have something called a state space explosion. Meaning that this entire approach doesn't work to infinity, meaning that the boss can come back and say, can you please filter by size or color? So either the size matches or the color matches. Imagine if you have, instead of just having size and color, you have 3 criteria. And you want to filter using the AND operator, you want to filter by all combinations. That's going to be 7 different methods. Because you filter, let's say you filter by color, size, and price. So you have color, size, price, color, size, color, price, and then all 3 of them. So that's 7 different methods. There is no way we're going to write 7 different methods for actually performing this kind of filtering. It's not practical. You have to have a different kind of architecture for implementing this. And this is where we come to the specification pattern. So the specification pattern is going to take us away from this approach of exploding numbers of methods, and it's going to allow us to write something which is very modular and very easy to work with. So what is the idea? The idea is that whenever you want to have a particular filtering criteria, you specify a separate class which defines that sort of filtering, and that class is called a specification. So for example, for a color, you can have a class called a color specification. So a color specification can it gets initialized by you specifying what color you actually want to filter by. So let's have the color here, and you have some sort of method like is satisfied. And this method gets called to make sure that a particular item which is fed into the specification actually satisfies whatever this criteria is. So in this case, the item color has to match exactly to the color we specified in the constructor. In a similar fashion, what you can do is you can define, for example, a size specification. So a size specification would look exactly the same. You have a constructor which takes a size, you save that size, and when you implement is satisfied, you just check that the size matches. Now, you might think, well, this is a bit of an overkill. This is a bit too much, perhaps, for us to kind of construct. But the consequence is that now every single filter is untied from another. So the specification here is not related to the specification here, meaning that if you need a new specification, you don't modify any existing class. You just make a new class, which also has a constructor which takes some criteria maybe, and it crucially, it has an isSatisfied method. Now, where is this method actually used? Well, it's used in a filter, but we're going to build a better filter. We're going to build a filter which is based on specifications. So we're going to have a class called betterFilter. Let's actually, let me take it down here maybe. So I'm going to have a class called betterFilter. So betterFilter is also going to have a method called filter, which takes a bunch of items as well as a specification. And here the thing is that we're going to filter. So we return items.filter by checking the specification against every single item. So you take an item X and you make sure that the specification is satisfied whenever you call it on X. So if the specification is satisfied, you get that item. If it's not satisfied, then you don't get that item. So let's actually take a look at how all of this can be put into practice. So I'm going to make a betterFilter. So a betterFilter here, and let's try finding all the green products. Let's take a look at how that would work. So green products using the new approach. Okay, so here you would say for let p of bf.filter, and here in the filter you have to provide two things. You have to provide the set of items as before, which is products, and a specification. So here you have to provide not just a color or a size, but any specification which is applicable to items. So here I can make a color specification providing the color green to initialize the specification, and then I can output all of the items. So here I can say p.name is green. All right, let's take a look at how this works. So as you can see, we're getting the same output as we did with the old approach, but this approach is better. This approach is better because it's a lot more flexible. We'll see additional flexibility in just a moment. So this is how you get apple is green, tree is green. So we got all the green products. If you wanted to get all the large products, you would make size specification, and in a similar fashion, you would find all the elements that are large. Now the question is, what about items which are large and green at the same time? Now, in order to implement this with the specification pattern, what we need to do is we need to build a combinator. A combinator is itself a specification which combines other specifications. So it's basically a class, let's call it AndSpecification. So this class is going to have a constructor which takes any number of specifications, which I'm just going to store them. I'm just going to store this.specs equals specs. So you can feed several specifications, and this specification is going to require that all of them apply. So when we go to implement isSatisfied, where you provide the item, here's what we do. We make sure that every single item in the spec is satisfied. Every single specification is satisfied by every single item. So we return this.specs.every, and the item gets checked according to this specification. So we take the specification and we say, is the specification satisfied by the item provided here? And that way, the only way that we're going to get a true out of this method is if every single specification from this.specs actually got satisfied. So let me show you how this can work, so we can find all the large and green products. So here, large and green products. So I'm making a composite specification now. So I'm going to say let spec equals new and specification. So we need to combine two things together. We need to combine a color specification for a color green, but we also need to combine it with a size specification for size large. There we go. So this is our specification. And then for let p of bf.filter, what we can do is we can feed that specification into the filter. So we provide the products and we provide the specification we just made, this composite specification. And then we once again can output the fact that a particular item is both large and green. So p.name is large and green. And if we run this, we get a tree, the only item which actually matches both criteria. It's both large and green. So this is how you make combinators. And in the same vein that we made an AND specification right here, you could make an OR specification, for example, or even an XOR specification, stuff like that. So what is the takeaway from this entire lesson? Well, first of all, the idea of the open-close principle is that classes are open for extension but closed for modification, meaning you never jump into an existing class and start to modify it. unless you absolutely have to, unless there is like a bug in there, then yeah, but extending functionality is not such a good thing, because remember, product filter is something that other people might have just copied your class wholesale and they're using it, and you modified it, but it doesn't really affect their code because they just took a copy. Having something that has already been tested and put into production, modifying it explicitly might not be the best idea. And in some cases, it's completely fine. In some cases, if you're completely in control of your code and if there are no heavy dependencies, there is really no problem in doing it. But generally, it's not such a great practice because it affects scalability, it affects maintainability of your code. So it's not a great thing. So a better approach is to basically use inheritance, or use some sort of way of extending functionality. Now, typically in object-oriented programming languages, the specification classes would have some sort of base class. You would have some sort of kind of abstract class called specification. Now, in JavaScript, obviously, there is no abstract class, but you could just force it in the constructor by making sure that if somebody calls the constructor of specification, then they get an error. And here you would specify the interface. Here you would specify is satisfied item, and then you would get other classes to extend specification, thereby they all sort of become a specification in a way. Unfortunately, in JavaScript, it's not really so strict, meaning that if you forget to implement is satisfied, then everything is still going to function. It's just going to be a no-op, basically. It's going to take this implementation of is satisfied, and that's not a good thing. So in JavaScript, things are a bit different in that there is no real need for a base class like specification. You could just do away without it and use duck typing whenever you provide specifications to a filter, for example. But generally, the idea is that you use inheritance of some kind, or at least you use this separation of concerns. Effectively, you separate each criteria by which you want to filter into a separate specification, like a color specification, a size specification, and then you can build combinators out of them. You can build large Boolean expressions out of these and specification or specification definitions, and then you can feed them into a filter which can subsequently process it better. So a filter which knows about specifications and knows about verifying them internally. So that's all that I wanted to mention with respect to the open-close principle, but we are going to mention it in other lessons in the course. So stay tuned for more examples of where it is adhered to and where this principle is in fact broken as well.